your pencil. It will not do anything. Okay, so this derivative, we need to find the rule for the arcsecant, correct? I knew that was going to happen. Okay, so I don't really need it now. So the derivative of the arcsecant is negative u prime over the absolute value of u square root of u squared minus 1. So that's the rule we're using. So that's the derivative of the cosecant of u. So what's the u in my problem? U is x over 3, and what's u prime? 1/3. Okay, so my derivative, f prime of x, please watch, the fractions will hurt you when we're doing the simplifying afterwards. The derivative is easy. It's simplifying the fractions to get rid of the complex fractions that will make you crazy. Yes, they will. Okay, so negative 1/3 on top. So what did I, from the last problem where we had a fraction on top, the 1 can go on top and the 3 can just go on the bottom with the rest of this junk.
Mumbo jumbo.
Yep. So now what's going to go in place of the absolute value?
X over 3.
X over 3 goes inside, and then the square root of x over 3 quantity squared minus 1. Now, you cannot leave it like this. This is a complex fraction, meaning it's got fractions in a fraction. We have to change it. So, we are done with the derivative, but we can't leave it like this. So, now the x is the part that could be negative, right? So we would have to leave that in absolute value, but that 3, what's the absolute value of 3? 3. So what I can do to start out is say, well, that's the same as 3 times the absolute value of x just divided by regular 3, and then what happens to the 3's? The 3's cancel. So you can cancel those 3's. So now you've got, I'm going to write this below here, f prime of x. You'll have negative 1 on top, and you'll just have absolute value of x down here. But we still have this. But what's x over 3 quantity squared? X squared over 9 minus 1. Now, there is not a rule. There never has been a rule. You made it up if you think this is right. You cannot take the square root of this and the square root of this separately because of the subtraction. You cannot do that. It will never be right. The only time you can do it separately is if it were multiplication between there or division. Then you can do the square root of the top and bottom or each thing being multiplied. This, nothing you can do. But this is a fraction, this is a number. What can I do with these two things to make it into one fraction? Common denominator. So what's the common denominator here? So how can I rewrite 1? 9 over 9. So what I really have is negative 1 over the absolute value of x, and then the square root of x squared minus 9 all over 9. Now I can take the square root of the top and the bottom separately. That's a rule. So we still don't know the square root of the top, so we have to leave that still. So I have negative 1 over the absolute value of x, and I leave the square root of x squared minus 9. But what's the square root of 9? 3. And that's on the bottom here. So isn't this whole thing a fraction? So we're taking this big fraction divided by this fraction. Negative 1 divided by this fraction. How do you divide fractions? Multiply by the reciprocal. So really, where's the 3 going to end up when you do that? On the top, and this is going to end up on the bottom where you see it now. So my final derivative, all simplified and pretty without any fractions and fractions, is going to have what on top? Negative 3, and then on the bottom the absolute value of x and the square root of x squared minus 9. And that looks so much nicer than what it did all the way up here. And you do have to do that. And that you'll run into it maybe a couple times on your homework. Couple. Yep. So I think I've given you examples of all of these that you'll need, and I'm going to totally change your homework assignment. And I don't really know what I was thinking. I'm going to actually get rid of a homework assignment, so I don't know if we want to call this 28 and 29, or I don't know. Okay, let's just completely cross out homework 28. Completely cross it off. And then I'm going to change homework 29. So I'm going to change that completely. Because see, if I just skip the 28, then we can just keep going. I don't want to rename everything, so.
We did that last time. You like combined or something?
Yep, I did. So we're going to do, starting on page 377, you're going to do 6 through 33 by 3s, not by 6s. And then you're going to do problems 42
I heard by 9 that you guys.
through 52 even. And then I'm going to add one more problem. I'm going to add number 64.
That's a whole assignment.
Yep. And I'm going to give you an extra credit problem. Extra credit will be 94.
Darn it, it's not done.
And 94 has parts A, B, C, D, E, and F. Problem 94, you pick one of them and prove it. I wanted to do the proof, but you wouldn't let me.
Wow, we good job.
So, you get to pick one of the inverse trig functions to prove where the derivative formula came from. So that's extra credit. So you pick one of them. If you do all of them, I'll pick your best one and give you extra credit for it. You will not do all of them, I can guarantee you that. Okay, I shouldn't say that because someone will.
Yeah. Do it, Dylan. There you go.
Not doing so Monday.
Yeah. Because that's what Dylan does on Saturday nights is math.
Sunday night.
I have math parties all weekend, so you have no idea. It's so much
Is there
fun.
alcohol at those parties? She's kidding.
I choose not to answer that question. I am 21. Much older than 21, yes. Okay,
You don't look 21.
that is on the video.